All right, so 8 and 9, when we take a look at 8 and 9 and they ask us, it's so important that we're reading the directions on these. We want to write it in radical form. So if you guys remember, when we have our fractions, we always say power over index. Power over index. Now on a radical, this is called the index, the number that's on the outside of the radical. It's a small number, but it's on the outside. And then of course your power means the same thing as the exponent. So the power will still stay here, and we could actually put it in parentheses where you're writing that on the outside. But again, the index is in the little upper left corner of the radical. So when I want to convert it to radical form, the 3, the base is still staying underneath. The index is the one on the bottom, so this is called the cubed root of 3 to the 4th power. This time it's the square root, the index is 2, the big base of 5 is here, and it's the power of 5, so we're going to raise that to the power of 5. Now when our index is 2, we don't really need to write it, because it's already in the name the square root. Those are our final answers. So we want to apply that knowledge as we go to simplify some of these. So we're saying power over index. Now this one also applies that drop it like it's hot rule. So we want to form a fraction now where there's a 1 in the top and the 343 is going to the bottom of the fraction because of this drop it like it's hot rule, our negative exponent rule. So our index on the radical is 3 and the power is 1. Well, if the power is 1, you don't actually need to show it. So this, when I simplify the radical, it's just going to become 7, 1 over 7. Okay, so remember power, index. We've got the 5th root of 32, and now this time it's to the 4th power. Well, I want to simplify underneath first. So the 5th root of 32 will become 2. Don't forget about your power of 4. We haven't done that yet. And 2 to the 4th is 16. When we take a look at 12 and 13, those are applying our power, our product rule, where if we had x to the 2nd times x to the 4th, you're probably asking yourself, does it become 6 or does it become 8? It'll become 6 because what you're doing is you're adding these. So that's the same idea here. We want to add these two fractions. Well, the nice thing is they already have a common denominator. So you get to just add the top, which will become 6. The bottom will stay a 3. So if I reduce this, it'll become a to the 2nd. Well, in number 13, they don't have a common denominator, so you kind of have to deal with that separately. On your calculators, though, you should use your alpha y equals, or just use parentheses if you have one of the older calculators, and use your math enter key. Okay, so if you needed to get common denominators, the second fraction will stay. This one gets multiplied by 2, but don't do that by hand. Let your calculator do the work for you. This will become 11 over 4. So I'll call this p to the 11 over 4.